Hi guys, myself Marisha from Sri Teacher College of Engineering, USN 97, subject analysis and design algorithm, SEM 4 SEM. Introduction to sorting algorithms. Sort, Sorting algorithms are fundamental tools in computer science enabling the efficient organization of data from simple comparison to advanced techniques. These algorithms underpin numerous applications and optimizing search and storage and retrieval. Understanding their principles and performance characteristics is a crucial for effective problem solving system design. Fundamentals of insertion sort. Insertion sort is a simple and initiative sorting algorithm that works by initially iterative building and sorting portion of the input array. The algorithms works by taking one element at a time from one unsorted part of the array of and inserting it into its correct position within the sorted portion. This process is repeated until the entire array is sorted. The key idea behind insertion sort is that sorted portion of the array acts like a partially built house, and each new element is inserted into new proper place, much like carpenter inserting a new brand into house under constructions. This incremental approach makes insertion sort efficient for small and partially sorted arrays. The animation above depicts and step by step the insertion sort algorithm, showing how much new element is inserted into the correct position within the growing sorted of the array. Time complexity of insertion sort. The time complexity of insertion sort is n 0n square, which means that as the size of the input array increases, the time required to sort the array grows quadratically. This makes insertion sort for smaller data sets, but it becomes computational expensive for large inputs. The reason for this complexity is that insertion sort works by iterating through the array. For each element, it compresses it to the elements before it and insert into the correct position. The process of comparison and insertion takes zero of n time for each element, leading to a overall time complexity 0n square. However, it is important to note that the time complexity of insertion sort can be improved in a certain cases, such as when the input array is already partially sorted. In such scenarios, the algorithm can take advantage of the existing order and reduce the number of comparisons and swaps required, resulting in a better runtime performance. Advantage and disadvantage of insertion sort. There are three types. There are three. Simple implementation. Insertion sort is known for its simplicity and ease of implementation. The algorithm works by iteratively inserting the element from unsorted part of the array into the correct position in the sorted part, making straightforward process to understand and code. Second one, efficient for small data sets. Insertion sort performs well for data sets. Its time complexity is 0n square in the average worst cases. For small arrays, the constant factors involved make it practical choice and compared to more complex sorting algorithm. In place sorting. Insertion sort is a place sorting algorithm, meaning it only requires a constant amount of extra space to perform the sorting and making it memory efficient for large data sets. Fundamentals of topological sort. Topological sort is a powerful algorithm used to order the elements directed a cyclic graph in a cyclic fashion where each node appears before all the nodes. It depends on this ordering is crucial in scenarios where tasks have dependencies such as scheduling projects, managing prerequisite courses, and organizing software build process. The key principle behind topological sort is to identify an dependency between the nodes and then arrange them in a way that respect those dependencies. This is achieved by traversing the graph and addressing nodes to the sorted list only when all their prerequisites have been processed, and the result is linear ordering where each node comes after all the nodes it depends on. Application of topological sorts. First one, dependency management. Second one, scheduling and workflow. And third one, course prerequisites. Topological sort is a widely used in a software development to manage dependency between tasks or modules. It helps to identify the correct order of execution, ensuring prerequisite tasks are completed before dependent ones. And second one, scheduling and workflow. In project management, topological sort is a employed to schedule tasks and optimize workflows. It determines the proper sequence of interdependent activities, aiding in efficient efficient resource allocation and timeline management. Course prerequisites. Academic institution utilizes topological sort to map course prerequisites, ensuring students fulfill the all necessary requirements before progressing and advance to courses. This helps maintain integrity of degree programs. Implementing topological sort in a ADA. First one, understanding topological sort. Topological sort is a fundamental algorithm in computer science that arranges the vertices of directed acyclic graph in a linear order. This order reflects the dependency between the vertices and ensuring that each vertex has come from before all the vertices depends on. And second one, implementing topological sort in a ADA. You can implement topological sort using depth first research. The DFS approach. This involves traversing and keeping track of the visited vertices of their dependency and building sorted in a reverse order. ADA pseudocode for topological order. The basic stuff for implementing topological sort in ADA are first one initialize a list to store the sorted vertices, and second one mark the all vertices and as unvisited. Third one, for each unvisited vertexes performs DFS and add vertices to the sorted list in a reverse order. And fourth one, return the sorted list. And comparing insertion sort and topological sort. First one, insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting an element from an unsorted position of their array into its correct position in the sorted up position. It has a time complexity of 0n square, making it efficient for small data sets but less scalable for large ones. And second one, topological sort. Topological sort is an algorithm that arranges the vertices of a directed graph in a linear order, such for every directed edge from vertex A to vertex B, and vertex A comes before vertex B in the ordering. This makes it useful for tasks like scheduling dependency or analyzing project workflow. Optimizing sorting algorithms in ADA. When it comes to optimizing sorting algorithms in ADA, developers must carefully consider factors such as memory usage, computational complexity, and performance on large data sets. One key technique is to leverage ADA's strong typing system to create specialized sorting functions to tailor the specific data types being stored, rather than relying generic sorting routines. This can lead to significant performance gain by eliminating unnecessary type of conversions, streaming the sorting process. Another important optimization strategy is to choose the most appropriate sorting algorithm for the task at a hand. For example, insertion sort may be more efficient for small, partially sorted database, such as while quicksort, merge sort may be better suited for larger and unsorted data. ADA developers can leverage and flexibility of the language, implement these algorithms, and select the one based on the specific requirement of their application.